I did my honors project on different wattages of light affecting crickets' behavior. The problem is, how does different wattages of light affect the behavior of crickets? The Acheta domestica cricket is commonly known as the house cricket, is found in the US. It is the cricket used in my experiment. Male crickets chirp during the night to attract mates, and that is going to be a key component of my hypothesis. So my hypothesis is that I hypothesize that if the light wattage increases, then the cricket's behavior will decrease because male crickets chirp during the night to attract their mates, and therefore more active in the dark, because since they try to attract mates in the dark, then they will definitely be more active because attracting mates takes activity. So for the procedure, the materials you're going to need is two 60-watt light bulbs, two 40-watt light bulbs, 120 crickets, 6 clear containers that are about 6 by 4 inches, an orange slice for food every 5 days for each container, and a dark place to put the containers, which you can see in the picture. I put it in my closet. So the procedure: put the 3 containers in a room that will stay around 70 degrees Fahrenheit. Put an orange slice and 20 crickets in each container. Place the lights above the containers, like matching which containers which. Every day record how many crickets are alive, how much they ate, and how much they chirped. And then repeat the experiment at the end. And also make sure to replace the orange slice every 5 days. So the variables in this experiment are, first off, the independent variable, which is the wattage of light bulb. And there is only one because there is only the light bulb that is affecting the crickets. That's different from each one. And then dependent variable is the cricket's behavior, in way that we measured that is how much they eat, chirp, and die. And the controlled variables are the amount of crickets, which would be 20 crickets in each container, the species of crickets, which would be the Acheta domestica, containers for the crickets, which would be about 6 by 4 inches, the temperature, which would be about 70 degrees Fahrenheit, the amount of food in the containers, which would be an orange slice every 5 days, and then the time the experiment starts would all be the same. So this is the trial 1 data. So for the no light, for the trial 1, you can see that the eating the orange, it varied a lot, but it was definitely more on the lower end. And then the chirping was higher than the other ones, but it decreased as the population decreased. And then the number of crickets alive, it also decreased at a pretty steady rate of 2 after the 4th day, but it was higher than the other ones. And then the 40 watts trial 1, the eating of the orange was around moderate. The chirping was a little less than the no light, but still a good amount. And then the number of crickets alive after the 2nd day, it went down by about 2. A couple times it went down by 3. And then the 60 watts trial 1, the eating the orange was closer to high than moderate, and the chirping was a little bit lower than the other 2, but still pretty high. And the number of crickets alive after the first day, they started to drop off, and they would drop off by like 2, 3, or 4 at a time. And then these graphs also show how this is expressed. So this is the trial 2 data, and you can see a lot of the same kind of trends happened in this one too. Again, the no light trial 2 was the eating was kind of on the orange was pretty moderate, kind of lowish. The chirping was the highest out of all of them. The number of crickets alive after the 2 day, which was a little bit shorter, they started to decrease, and the population was actually less. And the day for the 40 watts, the eating was around moderate. The chirping was a little less than the other one, and then the number of crickets alive after the 2nd day started dropping by about 2, maybe 3 sometimes. And then 60 watts, eating the orange was closer to high again, kind of moderate still. And chirping, the chirps per minute was a little less than both of the other 2, but we're still pretty high. And the number of crickets alive after the 2nd day, it went down a lot. In a couple of days, it would drop down by 4. And again, these graphs show these and how they kind of correlate together. So these are the results of both the trials. So in basically both the trials, the no light container had less deaths, more chirping, and less eating of the orange slices than the 40 watts and the 60 watts. The article I researched proved that crickets mate more at the night, so therefore they will also be more active in the dark, and that just kind of strengthens my hypothesis. And the advantage of the experiment was that the area that I did it in was completely dark. The disadvantage was that the light between the containers could have contaminated each other because I tried to separate them, but it was like a pretty small closet. And then the human error would be shaking the containers to see if the crickets were alive, because obviously that can like affect them in negative ways and could decrease their activity or increase it. So for the additional results, the general theory is that crickets will be more active in the night because they mate during that period, and because of this mating, they will be more active because that's what crickets are usually when they're mating, they're active. And some of the questions that were unanswered through this experiment was how well would a container of crickets do with natural light? Like basically you'd put the same experiment that I did, but just with like next to a window to see how well they would do, and you could compare them to the other ones. And then how much reproduction takes place in the different wattages of lights and no light. So since I did the experiment under a 15-day trial, like they didn't have time to reproduce and actually like make a lot of offspring, so we couldn't really tell how much they would reproduce, which it would be interesting to see if they actually would or not. And could the population grow? So under the circumstances of my trial, it would be very hard for them to grow because I just put them in a container and had some light shine on them. But if you somehow got to replicate their natural environment, but still have those lights that shine on them and see like how the population would change, and I think that'd be cool. For the conclusion, the experiment was supposed to test how active crickets are in different wattages of lights. That was the main purpose of it. The result is that as the wattage of light increases, the activity of the crickets decrease. And this does support my hypothesis. It supports it through my findings of my experiment because it proves that as the wattage of light increases, the behavior will decrease because there was less chirping and more deaths as the light increased, and because of that, the activity of the crickets increased as the light decreased. So thank you for listening, and I hope you have a great day.